Welcome. My name is Andrea. I work for GeoSolutions, a company, an international company with offices in Italy and the United States. We support and participate in the development of a number of open source projects. We believe in open source, in open standards, and of course, as a result, we are involved in OGC API, at least to some level. So let's have a look at very quickly at the common elements of OGC APIs. It's a fresh take on spatial data interoperability based on OpenAPI and RESTful concepts. So you have resources, you have representations, you have HTTP verbs or methods. Each API is based on a small core, a basic service that can be literally implemented in a matter of a few days, and extensions for every other functionality. And the core tends to be really, really small. The common is specified in OGC API common, which you can find at that address. It adds the idea of a landing page, which is your entry point to an API. A conformance declaration, which is a list of conformance classes which specify what your specific implementation does and does not, by extension, do. For services that do expose data, not all services do, then you have also collections and the notion of a single collection resource. Linking is a very important aspect in all OGC APIs. Every resources are linked with each other. APIs are browsable. You can land on a landing page and reach everywhere or almost everywhere. We will see one exception by following links. If you have an HTML representation of resources, you can do so from your browser. So very easy to get into them and learn them by just playing. Each resource has a representation. Can have multiple representations. OGC API Commons recommends HTML and JSON as two possible representations. They are not mandatory. Most implementation of services implement JSON. Some implement HTML. You're free to implement whatever other representation you want. How do you choose the representation? By using the accept header, just like any regular HTTP client. Or eventually through a custom query parameter. OGC API Common makes the example of using F that you can use whatever you want, really. As long as you just bake it into the links. The client don't need to know what parameter you use, they just follow links. Extensions and conformance, as I said, tiny core, bare minimum, and modular extension for everything else. And this is HTML representation of a conformance class page from GeoServer from OGC API features. Common bits of the GeoServer flavor of OGC APIs. OGC APIs are very flexible. They can be implemented in a variety of ways. What's the GeoServer take on it? One service per API. We don't do the giant tree with all the APIs baked all together. We have an approach that mirrors the classic OGC services. So we have an OGC API features service and then an OGC API task, but they don't overlap. So it matches one-to-one the classic OGC services, and implementation-wise, we have the classic OGC service and the OGC API talk to the same internal engine. So basically, there is a level that handles the protocol, how you make the request, and how the responses should be generated, which talks to an internal engine that accesses data, does stuff, filters, projects, whatever, and then returns the responses. So as a result, you will see that the OGC API implementation mirrors the functionality of the classic OGC service pretty closely. I already said that. Okay. We have HTML representation for each and every service, unlike other OGC APIs, like many STAC services, for example, tend to have only an a JSON representation for resources. We have one in HTML that can be customized through templates. So you are in control, you can customize the way it looks, the logos, and the contents as much as you like. We just give you a data model and you do whatever you want with it. And we'll see an example from DLR, the German Space Agency. Links are also customizable. GeoServer puts in the basic links that the specification mandates should be there. But you can add whatever link you want in addition. We did this work under the sponsoring of GeoNovum for Inspire compliance, because the OGC API features flavor of Inspire requires extra links which are normally not there in GeoServer, such as license, described by, enclosure, links that allow you to do extras. We made it configurable because we didn't want to have a rigid Inspire implementation and then do another for another standard and so on. You just go and implement whatever link you want to abide to whatever standard you need to. Okay, let's have a look at the first service, OGC API features. The core, in addition to, well, OGC API commons, adds the notion of items inside a collection. The only supported CRSs are CRS84, that is WS84 in longitude, latitude order, mind the order, or CRS84-8H, which have the height. Schema is not required, unlike WFS. You can have schemaless services as much as you like. So it's not a you must do. You can. So in the specific GeoServer implementation, we tend to be schema-oriented because the core engine is schema-oriented. So the features do share a common structure, but at the specification level, you don't have to. You can have your own Elasticsearch with full of document with unrelated structures, and you can still publish it through OGC API features correctly. If you have a schema, then you can use the described by relationship to link to it. This is an example of the Swagger HTML representation of the API. Same items that we have seen before, nothing new. At the items level, this resource lists the content of a collection. So it's the equivalent of a get feature in WFS. The result is typically a GeoJSON document if you implemented the GeoJSON conformance class, but in GeoServer it could be also GML, KML, CSV, whatever. Basically all the output format that you would find in WFS are also found in OGC API features. In terms of filtering, you have bounding box in CRS84, datetime, single time, time range, and you could have extra parameters declared in the API document. We don't do that, which allow for filtering by equality. So you say CT equals Milan, for example. We believe that that's a little bit too rigid. It doesn't offer enough functionality, so we didn't end up implementing it. But this is an example of a request that uses all three approaches. Paging. An OGC API feature service is pageable. Every time you make a request, you get to the first page, and the first page has links that you can follow to get to the next page, and so on and so on. Every server implements the links whatever way they please. The client just blindly follows the links. Next relationship, you go to the next page. Prior relationship, you go to the previous page. That's it. Site compliance, through the GeoNovum sponsoring, we made GeoServer 224.x, which is the development branch, pass the OGC API core compliance test suite a month ago, give or take, maybe 2. Then there is part 2. Part 2 is CRS by reference. It's about supporting more coordinate reference systems than just WGS84. You can declare your storage CRS, that is how the data is actually stored, because we have to go out in CRS84 by default, so the projection on the fly is baked into the system. And then you have a list of CRSs that you can reproject to, and then you can make your own request. I don't have an example, but it's end CRS equals to whatever you want, and the OGC API features would reproject the data for you, turning it out in whatever format you choose. This is also compliant. We made it compliant again through the sponsoring of GeoNovum. Filtering. Filtering is in draft. It's not a finalized specification like the other two. It introduces the notion of queryables, that is the attributes that you can build a filter on. This is important, it's interesting. In WFS, you could query against every attribute, but let's be honest, in a database you never index every attribute, right? So there are attributes which are fast for filtering, attributes which are not well suited for filtering. With the notion of queryables, you can actually have a choice of what you want to make available for filtering. And then you have the 3 parameters, filter, filter lang, and filter CRS to specify your filter. So this part does not mandate a particular filtering language. It just provides a mechanism for filtering. And then there is another specification called CQL2 that you can use to provide a filter. CQL2 looks a little bit like the old SQL that GeoServer implements. Some parts are different. Some spatial and temporal operator names have changed, stuff like that. but more or less the basics are the same. And you have two flavors of it: SQL2 text, human readable filter, or SQL2 JSON, easily machine processable implementation of the same. GeoServer supports both. GeoServer supports sorting. Sorting is not part of any part of the OGC API feature specification. It's something that we borrowed from OGC API reference with a, I'd say, pretty sensible implementation. Sort by, and then the name of the properties you want to sort by. You want to sort the setting, you add a minus sign for pretty easy. Sorry. What is going on here? Okay, STAC API. STAC API is another API that we implement, and that has a finalized specification, or at the very least an RC. STAC API is a spatial temporal asset catalog. It allows you to search for the common case satellite imagery, but really anything that is located in space and time and that can be downloaded as files is a good candidate to be put into a STAC API. STAC API can be implemented as compatible with OGC API features, so you can have an API that is actually both, and that's how we do it in GeoServer indeed. In terms of implementation, we have the notion of a collection which contains products, your satellite imagery, and each product then contains in the parlance of STAC assets, which are typically the single raster files making up the bands and the metadata and whatever other information you might want to attach to the product. And GeoServer allows you to do searches, but also to do on-the-fly mosaicing of the contents of the images. Okay. Moving on, this is an example of customization made by the German Space Agency on the collections pages. So they customized the logos, part of the content, they add the pictures and so on, so that you have an idea of how powerful the customization subsystem is. OGC API coverages. This is a work in progress. It's a work in progress both at the specification level and at the GeoServer implementation level. OGC API coverages could be thought of as the simplest WCS error. It has been partially implemented during a code sprint. We participated to an OGC API code sprint, and in a couple of days we put together something. It's not complete. The idea is that you can take a collection. The collection is a coverage, and then you have a few sub-resources that describe the content of the coverage. You have one sub-resource which is the coverage itself, which is everything, all the data, all the metadata, but you can also have the domain set, the spatial component of the coverage, the range type, the bands, let's say, the description of the bands that are typed, how many, and so on. The range set, which is the pixels, and the metadata, which is everything else. When you merge these four together, you get coverage. So this is your presentation as GeoTIFF, NCDF, or whatever. And you can do coverage extraction either by bounding box or using subset. Subset is an interesting take on the axis order issue. You know, with using OGC APIs, you know that you are using WGS 84, but you're trying to use something else. What's the axis order? Well, with subset, there is no question, there is no doubt. You specify a range of latitude, a range of longitude. I could have done the opposite, it would have been the same, because I'm explicit about which axis I'm talking about. So, no more axis order problem if I'm using subset, at least in the requests. Okay, OGC API maps is another API which is in draft. It's an API which is specified from the ground up as a building block rather than a service like OGC API features. And we have a partial implementation of it from an OGC API code sprint. The building block is to produce map, so it can be attached to anything, any resource that can be mapped. You have a raster, you map it. You have a red vector, you map it. You have a WPX output process, you map it. So you attach /map to these things. The Maps API also introduces the notion of a style with a style identifier, just like in WMS, so that you can have multiple representation of the same resource. And then you have a map resource, which is to get the map. The nice thing about the Map API is that it looks a little bit like WMS, but no parameter is actually mandatory. Well, besides the collection name. You just say, I want a map of the United States, period. The server defaults everything else. You want a map in GeoTIFF, then say so. You want a map that is 1024 pixels, then say so, but you don't have to. Everything is defaulted. So there are parameters with height, pivot, CRS, and more, but you don't have to specify them. The info resource, I say GS specific. When we implemented the API, it was actually part of the specification, but then it was removed. It's probably going to be part 1 or part 2. In any case, not core, an extension. And it follows the same pattern. You specify I and J, those two are mandatory, to identify which pixels you are querying, and that's it. As I said, not part of the core. To be honest, even in WMS, it was part of the specification, but it was not mandatory. You could have done a valid WMS without feature input. No, almost nobody does, but it was valid. OGC API tiles. This is a work in progress from the point of view of the GeoServer implementation, but the building block for tiles is finalized. It's at this address. It also reads as a building block rather than a service. So the idea is that you have a resource that can be sliced into parts, then you can attach tiles to it. So you have a collection. I can tile the data, I can tile the vectors, I can tile the rasters. I have a map, I can tile it. I can do PNG tiles, JPEG tiles. I have, whatever, a process API that's building something, and then I can retrieve it through APIs. What does the block add? It has a tiles resource, and the tiles resource is interesting because that's one use case where you cannot just follow the links. Why? Millions and millions and millions of tiles. Can I do links to all of them? Of course not. It's not practical. So I have a URL template instead. So I have a recipe to get to the tiles. And then I read the tile limits that tells me for each zoom level which ranges are supported for X, Y, and Z. And then I know how to fetch the tiles. There is also, in some implementation, not part of the standard, a tiles metadata resource. GeoServer has it, LD Proxy has it, which is an interesting take about interoperability across ecosystems. So the metadata resource is about describing the tile set again, but in a way that is not the, let's say, the normal OGC way. And in both LD Proxies and GeoServer, we do the JSON implementation of the resource as TileJSON. TileJSON is an open specification by Mapbox, which a Mapbox client can read in order to fetch tiles. So they read this specification for either PNG tiles or vector tiles, and they know how to interact with the API. They will interact with an OGC API without even knowing it, because we trick them into building the right URLs. Other APIs. So we have an implementation of OGC API styles, which is an interesting new API. All the APIs that I gave you so far had an equivalent in OGC services. This one is new. If you are GeoServer users, you know that we have a style catalog inside GeoServer, but it has always been something like private. The name of the styles pop up in the WMS service, but you don't get to read the styles. Fast forward to today, you got clients that can get vector tiles and render stuff on their own. But where do they get to the styles? Do they have to start from scratch? That doesn't seem reasonable. You could expose a style catalog instead, and this is what it is. Styles API allows to search and inspect styles and download them in a variety of representations if you have them, and eventually also to upload styles. Okay. And so you can do all these things which you couldn't do before. Another interesting API that we have a prototype implementation of in GeoServer is GGS API, Discrete Global Grid Systems, which allow to represent the world as a set of cells which are multi-resolution. We have two DGGSs here, RealPix and H3 from Uber. And the GeoServer has an implementation of that, and has an implementation of a DAPA, which is a processing API, which allows you to say something like, give me the average value of this band in this area. And we have an implementation based on a database called ClickHouse, which is very, very quick at doing calculation, especially if you store the data as DGS. Moving forward, next step, code. The OGC API in GeoServer is a community module. We need to bring it to extensions, but we need to wait for the relevant specifications to become stable. we cannot have an officially supported module with a specification that moves under its feet. So for features, we are waiting at the very least for SQL2 because it's kind of the bare minimum which we would consider. We need to complete the implementations and have more implementations. And what else? We hope to see more and more uptake. Right now we have like a few research institutes or innovation institutes that have invested a little bit in the development of OGC APIs, but we don't see uptake in the commercial sector. We hope that this is going to change soon. And with this, I'm done.